All right, ladies and gentlemen, station 3. Again, if you're not at station 3, go back, find the right video, and watch it. This won't help you if you're not at station 3 today. All right, this is our triple beam balance. This is how we determine mass. Remember, in science class, mass is the same thing as how heavy an object is, okay? I know, science is crazy. Now, how this works. First thing you're going to look at is this side right over here. You're going to make sure this white line here is dead center on this 0, okay? If it's not, if it's a little off, that's okay. But if it's really off and doesn't look right, raise your hand, let me know. I may need to come calibrate it for you. But otherwise, we'll move on assuming that it is correct. Now, on here we have 3 different scales, okay? This biggest one is our biggest scale. It moves up at 100-gram intervals. This one back here is our middle scale. It moves up in 10-gram intervals. And this one way back here on the front is our smallest scale, okay? It moves up in 1-gram intervals or even less if we need it to, okay? So that'll be our last thing. How we operate this, we determine that it's level here. Then we take our object that we're gonna weigh, just a little brass weight today. Put it on here. You'll notice that it goes up. The goal of this is to get it back to being level, okay? If it's up above the line, we're too light. If it's down below, we're too heavy. So the goal is we gotta take our time and get it right in the middle. All right, so we always start with the biggest weight, okay? We move it up 1 interval at a time until it starts to do that. So we finally hit a balance point. And if you'll notice, it's pretty close, but it's just slightly below the line, okay? So we're a little heavy. So we're gonna back it up 1. So now we know we're too light again. Remember, up here's too light, down here it's too heavy. So now that we know it's here, we're gonna start on the middle scale. Move it up, same thing, 1 notch at a time. Make sure you're in these notches, guys. Don't try to halfway in between one, okay? It's not how this works, and it's not very accurate. So make sure it's in that groove. You should be able to feel it in that groove. It shouldn't want to move if it's in there. So you should have to pick it up slightly to move it. Getting close. Still getting close. All right, so still a little heavy there, so we need to go back 1 to there. So now we leave these 2 guys alone. Now we're up here to this last one. So we know this one's close, so we're gonna move it on over, and it's little. This is where we get our very fine tuning at, guys. So we gotta be super accurate on this. Get as close as you can. Don't do it from behind over here. It's much harder than it looks. Until we get it in here. Until we get that little white line that's right here, spot on. And once we do, we leave it alone. And then we record our numbers. So on this guy we have 200. This one we have 90. And this one we have 9.8. Okay, so we add all that together. So 200 plus 90 is 290, plus 9 more, so 299.8 grams, because this entire thing measures only in grams. That's how much this brass weight weighs. So at this time, you're going to record it into your middle slot again of the appropriate spot on your sheet. Then you're going to start working on your conversions. So in this one, make sure you're using the right conversion chart. This one will be for grams to milligrams. So in this one, you're going to multiply by 1,000. And then you're going to convert the grams to kilos or kilograms by dividing it by 1,000. Okay? You're going to do this for all the blanks. If you have a question, raise your hand and I'll come help you. All right, go get it.